Okay. During week 6 and 7, we'll handle the basic of public key cryptographic and message authentication. Okay. For week 6 course, we will cover the public key cryptography encryption structure and the application for public key crypto systems, public key cryptographic algorithms, digital signature standard, symmetrical key distribution using asymmetrical encryption. And finally, we will cover X.509 certificate. This figure shows public key encryption structure. This public key cryptography was first publicly proposed by DP and Hellman in 1976. This public key structure is based on mathematical functions rather than simple operation on bit patterns. As you know, the asymmetric cryptography, conventional cryptography, use the substitution and the transposition that change bit patterns. Okay. So the asymmetrical cryptography does not use mathematical function, but public key structure is based on mathematical functions. Number theory. Okay, so first, to generate a pair of two keys, public key and the private key, they first generate the large random number. And the key generation program, this is a mathematical function, generate public key and the private keys. So this public key encryption structure is asymmetrical. Okay. When you encrypt plain text and when you decrypt ciphertext, you use different keys. That is asymmetrical. Okay. Let's see the encryption with the public key. Okay, Bob want to send this plain text to Alice. Then Bob has the ring which contains other person's public keys. And Alice select Bob select Alice's public key. PUA and encrypt the plain text using Alice public key. Yeah. And then ciphertext is transmitted to Alice. So this plain text encrypted using Alice public key. When Alice received this plain ciphertext, Alice securely maintains Alice's private key. Okay. Alice can decrypt the ciphertext received using Alice's private key. Okay. Decrypt using Alice's private key. Okay. Then ciphertext can be decrypted into plain text. Okay. Let's see the other method. Okay, encryption with the private key. Okay, Bob encrypt plain text input using Bob's private key. Plain text, encrypt plain text using Bob's private key and send ciphertext to Alice. When Alice receives this ciphertext, Alice finds Bob's public key from Alice's public key ring. Then Alice can decrypt the ciphertext using Bob's public key. Okay, decrypt ciphertext using Bob's public key. Then he can generate plain text. Okay. Now let's see the applications for public key cryptography system. The use of public key crypto systems can be classified into three categories: encryption, decryption, digital signature, key exchange. For encryption and decryption, the sender encrypts a message with recipient public key. Digital signature, sender sign message with its private key, sender's private key. Key exchange, two sides cooperate to exchange a session key. Okay. Okay, let's see again the three categories for public key cryptography application. Okay. Encryption, decryption, and the digital signature, and key exchange. Okay. RSA and DPLMAN is basic idea of public key cryptography algorithm. Okay. The Ron Livers, Adi Samir, and Ren Adelman at the MIT, they proposed the RSA block cipher in 1977. Okay, the RSA block cipher is the most widely implemented public key cryptographic algorithm. Also, there is a DPLMAN key exchange method. DP and Hellman proposed the idea to exchange a secret key securely. Okay. DPLMAN method use the computation of a discrete algorithm. Let's see first the RSA algorithm. RSA algorithm can be divided into three parts: key generation, encryption, decryption. Let's see how the RSA algorithm generates public key and private key. First, select two prime number. P and Q are both prime. And calculate N, P times Q. And calculate phi N, P minus 1 times Q minus 1. And then select E. Between E and phi N, there is no common factor. And calculate D. D times E divided by phi N must have the remainder of 1. Remainder must be 1. Then the public key consists of two integer numbers, E and N. Private key, two integer numbers, D and N. It's a very big number. When encrypt plain text M, ciphertext C can be M power E mod N. Mod calculation means divide by N, and ciphertext is resultant remainder. Okay. Ciphertext C power of D mod n generate plain text. Same c power of d divided by n. Then the resultant remainder is plain text. Okay, let's see example. Actually, the old number, integer number, are very, very big. But here, we use a simple number, small number, to show how RSA algorithm works. Okay, PQ, we select two prime number, P and 3, Q 11. Okay, so let's see. 21, 22 are relatively prime because the factor of 21 is 173721. Factor of 22 is 1, 2, 11, 12. The only common factor is 1. So this 21, 22 are relatively prime. But 21, 24 are not relatively prime because 21 factor of 21 is 17321. Factor of 24 is 1, 2, 3, 4, 6, 8, 12, 24. The common factors are 1 and 7. So this is not prime. Okay, anyway, 3 and 11 both prime. And then calculate n. And this is 33. We call this n modulus because here encryption, decryption, here n is used. And calculate phi. P minus 1, Q minus 1, then 20. Okay, then we can select 3 because 20 and 3 has no common factor. Okay. And we can also select T7 because TE mod phi n must remain the most 1. Okay, this calculation remain the most 1. So now we generate EN333, TN733. Okay. We can use this equation for encryption, this equation for decryption. Let's see how big the real private key integers. You see, this modulus is very big integer. T, this is very big integer. So the human cannot memorize this big integer. How can we memorize this integer? We use the wallet. That's why we use wallet. Wallet. Okay. So in wallet, this private key number must be stored securely. Okay, anyway, RSA algorithm mathematics for key generation, for encryption, for decryption. Okay. RSA algorithm use mathematics. Let's move to digital signature. Digital signature use SHA-1. This is hash function, and present new digital signal technique. The digital signal standard was completed in 1996. Okay. Okay. The digital signature is used to authenticate the source, sender's message. Let's see how a private key, public key hash function is used in digital signature. Okay, Alice prepare data file and want to send it to Bob. Okay, Bob. And from data file, using hash function SHA-1 can generate hash value. This is message digest. Okay, encrypt this message digest using Alice private key. That is called digital signature. Okay, and Alice attach digital signature to the data file and send to Bob. Bob, when receive this document, separate data file and the digital signature. Then Bob decrypt digital signature using Alice public key, and this yield hash value. For the data file, Bob apply same hash function SHA-1 and will generate hash value, this hash value. Then Bob compare this one and this one. If two hash values are equal, then Bob can authenticate this document. This document was sent from Alice. Okay. Okay. Let's see symmetrical key distribution using asymmetrical encryption. Okay, Bob want to send message to Alice. First, they collaborate to share secret key K. Okay. And then Bob create message M. Then Bob calculate HMAC hash value. Input of HMAC SHA-1 consists of M and secret value K, secret key K, will generate HMAC hash value. And Bob send message M with the HMAC hash. When Alice receives this message, Alice calculates HMAC hash from the received message and K. We assume Bob and Alice share secret key K. And then this will generate HMAC hash. Then Alice verify the message integrity and the authenticity by checking whether the received HMAC hash equals calculated HMAC hash. Okay. Then let's see how this can be performed. How shared key, the secret key K they share. Okay. This shows how Alice and Bob share secret key KS. First, let's consider simple secret key distribution. Simple. Alice generate public key, private key pair, PUA, PRA. Alice generate public key, private key. And transmit a message which consists of PUA and identifier of A. Concatenate two informations and send this message to Bob. When Bob received this public key of Alice, Bob generate session key KS and transmit it to A encrypted with Alice public key. Yeah, this one. Alice public key. So encrypt KS the session key pub generated with the Alice public key received from Alice and send this to Alice. Then Alice decrypt this part using Alice private key to recover session key KS. Because only Alice can decrypt the message. Because Alice maintain this private key securely. Also, only Alice and Bob will know the identity of a session key. Okay. So this is how two sides share session key. The problem is this is why this simple. There is concern third party can intercept the message. Okay, this message. Then either relay the intercepted message or substitute another message. Then there is problem. There can be a problem. Such attack is mainly in middle attack. To protect from man in the middle attacks in the previous slide, now the public certificate must be used. Let's see this figure. Actually, this figure corresponds to the transport layer security, TLS, which works between web server and the web client, that is browser. This works between web server and the web browser. We call this protocol as HTTPS. So if HTTP protocol works with the TLS, transport layer security, then HTTP changed as HTTPS. Okay, this explains how TLS, transport layer security, works. Client first send hello to server. Server maintain its public key and private key. Okay. And the public key certificate. And then server send server's public key certificate to client. Okay, this is a public key certificate of server. When client receive this certificate, the client extract the public key of server from the certificate and generate session key and encrypt the session key with the server's public key extracted from the server-side certificate. When server receives this message, server decrypts this data by using private key and can read the session key, KS. Now, client KS, server also KS, they share session key. Then they can use the session key to encrypt all the data during the session. Okay. Now, let's see the public key certificate. Public key certificate consists of a public key, the user ID of owner, whole block signed by trusted third party. The trusted third party is CA, Certificate Authority. That is trusted by user community, such as government agency or finance institution. A user can present his or her public key to the CA in secure manner and request a certificate. When CA issue the certificate, the user now can publish the certificate to other persons. So anyone reading this user's public key can obtain certificate. Rather than directly obtain user's public key. Anyone can obtain the certificate and verify that is valid by way of attached trust signature. Certificate Authority CA signed the public key. Let's see public key certificate again. Okay, Bob requests his certificate to CA, trusted third party. And then CA using this data to generate hash code. And this CA encrypts the hash code with the CA's private key to form signature, this signature. Then this total part, the Bob obtains certificate. And Bob publish this certificate to other persons. Okay, let's see the case Alice needed to use Bob's public key. Then Alice obtained Bob's public key certificate. Okay, Bob's public key certificate contains Bob ID information, Bob's public key, CA information, and the sign. This is this signature by this CA. And Alice obtained this certificate, hash this data, and create a hash value, and decrypt this signature part with the CA's public key, because Alice already has CA's public key. That's why we call CA as a trusted third party. Then recover hash value. And then compare this to this. If two hash values are equal, then Alice can obtain this Bob's public key securely. Okay, public key certificate, the standard is X.509 certificate. It's usually is ITU recommend this certificate. International Telecommunication Union is used for directory service to all users. Okay. Okay. Okay, let's see the X.509 certificate format. As version increase, the contents in the block in certificate extended, but let's check for version 3. Okay. First, certificate begin with the block, a version. Certificate the serial number. This is important. And the signature algorithm identifier. This part is signature. Signature algorithm identifier explain how signature can be obtained. And the issue name. This is a trusted third-party name. And valid period. This certificate valid, only valid from this time and to this time. And then subject name, the owner of this certificate. And the subject is public key information. Yeah, this is public key information. And the issue unique identifier, third party's unique identifier. Subject is unique identifier. Owner, certificate owner's unique identifier. And the extension, and finally, signature part. Okay. Also, there must be a certificate for revocation. We call CRL, Certificate Revocation List. Certification revocation list is last part the same signature, but here contains revoked certificate. The certificate not valid. So revoked certificate here indicate certificate serial number, this number. Revoked certificate and the revocation date. Even during this valid period, this certificate can be revocated and then indicate the revocation time here. So here list of revoked certificate. Okay. Okay. Obtaining user certificate. The user certificate generated by CA, trusted third party, have following characteristics. Any user with access to public key of CA can verify the user public key that was certified. Because no party other than certificate authority can modify the certificate without this being detected. So other party cannot modify the certificate without this being detected. Because certificates are unforgeable, they can be placed in a directory without the need for directory to make a special effort to protect them. Okay, X.509 Cert CA hierarchy. Alice want to obtain Bob's certificate. This means this Y means owner of public key. V is CA, who signed the certificate. This. Okay. So Alice want to obtain Bob's public key. But Jet signs public key. But Alice does not know the Jet's public key directly. Instead, Alice can obtain Bob's public key. W's public key. Then, using W's public key, obtain V's public key. Once obtain V's public key, it enables to obtain Y public key. Once obtain Y public key, it also enables to obtain Z public key. Then using Z public key, obtain Bob's public key securely. Okay. So this is a hierarchy. Okay, here. Z signs Bob's public key. Y signs Z public key. Okay, here V signs Y's public key. Okay. Here. W signs V's public key. Here. X signs W public key. So Alice already knows X public key. Then he can finally obtain this Bob's public key. Okay. Okay. Let's see the revocation of a certificate. Each certificate includes a period of validity. Certificate say from this time to this time, this certificate is valid. Typically, a new certificate is issued just before expiration of the following one. So it may be desirable on an occasion to revoke a certificate before it expires for one of the following reasons. First one, the user's private key is assumed to be compromised. User is no longer certified by CA. Reason for this include the subject's name has changed. Birthday has changed. So this shows statistics of the certificate revocation region. Secret key compromise. The secret key means CA's secret key, a private key, also owner's private key also. Most of the case corresponds to this key compromise. Next portion is cessation of operation because of this reason. Subject name change, birthday change. Okay, again, this certificate revocation list is like this. Okay, revoked certificate list. Okay. And finally, include the signature of this issue. Okay. The reason for revocation, the user's secret key is assumed to be compromised. This means secret key is private key. The user is no longer certified by this CA. CA's certificate, secret key, is assumed to be compromised. Okay, during week 6, we cover public key encryption structure, obligation for public key cryptography system, public key algorithm, digital signature, key distribution, X.509 certificate. Okay. I'll attach in the eCyber Campus this part PPT. Okay. You read and okay, study this part: authentication, security function, SH function, HMAC. Okay, this is homework, reading assignment. Okay.